All right, so our first speaker of the day is very exciting. We're going to have none other than the creator of Vue and Vite, Evan Yu, come up on the stage. And we're so lucky that he's here in person this year to bring us the state of the Vuenion with new and exciting updates from the Vue with Vue ecosystem. So welcome, Evan Yu.
Finally. I hope UFC fans get the reference. It's time.
Introducing first, fighting from Singapore by way of New Jersey, USA, presenting the creator of Vue.js, Evan Yu!
Oh, man. Thanks, Luke. That was great. Okay, hello, everyone. I'm super excited to be back here. Oh, that's a lot of clap. And so I want to actually just get a quick idea. How many of you have been here before? Raise your hand. And first-timers? Wow, this is awesome. So it's a little bit crazy to think about. Last time I was standing on this stage was 3 years ago, right? Literally 3 years ago. So super happy to be back, super happy to see everything going back to normal. And it's also a little bit crazy to think about last time I was here, these things didn't even exist or wasn't released yet. So Vue 3 was not stable. Vite did not even exist. Volar didn't even exist. Pinia, Vueuse, Vitess, Vitepress, Histoire, a lot of these new exciting things that's happening in the ecosystem didn't even exist. So the 3 years, we are seeing a lot of, we essentially created a whole new ecosystem around Vite, and along with that, we have all these new exciting things built on top of it, not just within the Vue ecosystem, but like even connecting all the other frameworks as well. So a lot of things happened. But now let's get back to the focus to Vue itself. So a quick recap for last year. So February 7th last year, so exactly around 1 year ago, Vue 3 finally became the new default version. So right now, we're pretty much 1 year in with the default switch, where Vue 3 is now the default version. So the adoption is looking great, because essentially over the course of 2022, we're seeing Vue 3 usage essentially tripled over the course of time. I think it's important to note a lot of the legacy projects probably stay on Vue 2, so vast majority of these adoption are actually from new projects that's starting on Vue 3. So in the past year, we invested a significant amount of energy into just making the overall IDE and TypeScript support around Vue 3 more solid. So Volar 1.0 was a really major milestone for us because it essentially resolved a lot of the long-standing issues around IDE TypeScript support and also command line TypeScript integration for Vue single-file components with greatly improved performance. So Vue TSC, which is the command line utility that allows you to type check normal TypeScript files alongside with Vue components, now also supports watch mode and supports emitting type declarations for your single file Vue components. So this essentially brings up the TS experience for Vue single file components to the same line with normal TS files. So great shout out to the work by Johnson, who isn't here, but if you see this, Johnson, you did a great job. Thank you. So Vue 3 ecosystem maturing. Nuxt 3, we saw tons of exciting updates about Nuxt. Once it got to stable, the team just started cranking out new exciting features. And some of the most important pieces in the ecosystem where people rely on, in particular UI frameworks like Vuetify, Quasar. We have also Vue 3 new options like Naive UI, Prime Vue, and not to mention Vueuse, which is essentially your go-to solution if you're looking for something that you don't know how to do yourself. Just check Vueuse. It probably has a solution for you. So we also shipped Vue 2.7, brought built-in composition API support back to Vue 2 with script setup, CSS vbind. So this aligns the base DX If you are using Composition API, now even both on Vue 2 and Vue 3, you can get pretty much the same experience. So this is also the long-term goal for us to bridge the gap and just bring the two versions closer. So even if you have to stay on Vue 2, you won't be missing out too much for the time being. So looking ahead for 2023, so we're still in this period of transitioning from Vue 2 to Vue 3, right? A lot of users, especially big projects, stay on Vue 2 or considering the option to migrate to Vue 3. So stability is still key. We believe that script setup and Composition API is in a pretty good place. Options API is here to stay. So we don't want to make drastic changes that would force you to consider, oh, should we rewrite our code base or anything like that? So this is a pretty important consideration for us. But at the same time, we do want to start doing smaller and more frequent minor releases. So in the past a year or two, because I was investing a lot of time into Vite and other related ecosystems, so Vue 3 itself, we intentionally wanted to just leave it stable, let people slowly get into it. But now that I believe we're in a pretty good spot for me to move the focus back to Vue core and start shipping more features in Vue 3 itself. So in order to facilitate this plan, we recently did some core infrastructure, Vue core infrastructure improvements in the Vue 3 repo itself. So 3 important things we did. The first is introducing ecosystem CI. And then we essentially completely rethought about the test setup, the build setup, just to make everything faster, make it easier for contributors to get a better development experience. And for myself, obviously, because I have to work on it day to day. So ecosystem CI is adapted from Vite's excellent ecosystem CI implementation by Dominic, who is here at the Vite panel. So ecosystem CI allows us to essentially have a place where we can pull in integration tests from ecosystem projects that has Vue core as the dependency. For example, you can pull in Nuxt or VitePress or the Vite plugin Vue. All of these projects, we pull them in and run their test suites using the latest commit or arbitrary commit that we choose from the Vue core repo. So the CI process will automatically allow us to say specify a commit or a release tag or anything. It'll pull that commit from the Vue core repo, build it from scratch, and use a local mock npm registry to publish them to simulate the actual installation process as much as possible from these downstream projects. So these downstream projects will actually install Vue from the mock registry, npm registry, and then run their test suites. So we'll start doing this probably on a fixed schedule, and also anytime we do releases, before the release, we'll run it, make sure we don't accidentally break anything. In fact, this setup has already helped us catch quite a few issues in the new build setup itself. So I think it was the right decision to do this before we started doing big refactors on the whole build setup. So faster test setup. We migrated the Vue core repo from Jest to Vitest. So going full circle, we're finally adopting Vitest itself at the root of the whole ecosystem. We migrated 175 test files, including 2,600 test cases. And I did that in one day. So I mentioned yesterday I wrote a simple script to convert some of the common things. It's mostly just changing the API being called from Jest to Vitest itself. And other than that, not much has changed. When we disable threads, the unit tests on CI went from 1 minute 38 seconds down to 32 seconds, and the local test feedback speed also increased significantly. We also implemented a faster build setup. So before I go into the details, a comparison. Previously, Vue core's setup wasn't really optimal, right? There had always been this room for improvement I've always wanted to do, but it was kind of risky without the ecosystem CI in place because it involves potential different outputs, different type generation. So after ecosystem CI was in place, I went ahead and did it. So now the build plus type check plus generating all the type declarations for all Vue internal packages. Before, it took over 3 minutes, close to 4 minutes. Now it's 18.8 seconds. So that's a 12 times speed improvement. So the details of what we did was we first moved from rollup plugin TypeScript to rollup plugin ES build. So now this change was challenging previously. I didn't do it in the past because, first of all, this removes type checking from the rollup build, which is in fact good because we can do type checking separately using just vanilla TSC. Now, plugin ES build has an issue because ES build when it transforms these files in isolation, we're not using ES build itself to bundle Vue because rollup still generates more efficient tree shaking, smaller bundles. But we use ES build for its speed. And when ES build is transpiling files in isolation, it cannot handle const enums. So that was the blocker which prevented us from doing this in the past. So this time, I actually sat down and wrote a custom rollup plugin. Just do the custom. Essentially, this plugin does constant enum pre-processing by itself. So it just converts all the constant enum usage to what TypeScript would normally spit out, and then let ES build to pick up the rest. So this is the major speed up that we saw. And we also moved from API extractor to rollup plugin DTS with a custom rollup plugin for internal API trimming. So essentially doing the same thing, but a lot faster. So these two combined give us a 12x speed improvement for building Vue itself. This is also, so this step was in fact kind of interlocked with ecosystem CI because previously the build process was so slow that it caused ecosystem CI to occasionally time out. So after we implement this, now ecosystem CI just runs very smoothly. OK, so now let's get into a really rough roadmap. This is going to be very high level. For Q1, the major focus will be quality of life improvements and bug fixing, because we do have a pretty long backlog of bugs that we do intend to address. So Q1 will be essentially a focus period where we just try to get the numbers down and ship some of the long-standing. There were a lot of PRs that were already ready. So the plan for 3.3 is being adjusted because the reason 3.3 has dragged on for so long was that we were hoping that we could land reactivity transform and suspense in 3.3. But after thinking hard about it, we decided that it is best to decouple the minor release cadence from these two experimental features for now and focus on other low-hanging fruits that we can ship earlier and faster. So some of the examples are external type support in script set of macros. So when you use define props, using the type signature, currently, if you that type signature includes types imported from an external file, it just cannot analyze it. But we intend to address that. Safe teleport, which JAM has implemented as an external package. We want to make that as the new default. And we have a bunch of TypeScript improvement PRs, which we did not merge, mostly because of worrying about the compatibility of newer TypeScript versions. So this is something we do want to address in 3.3 as well. And as you probably, some of you probably already are aware of, we are dropping reactivity transform. So reactivity transform was this experimental feature or RFC that's been going on for quite a while. We went through quite a few different iterations of it, hoping that we could further reduce the verbosity of having to use .value and improve the DX. But after going through this, shipping it, and actually testing it in real code bases, we found that the DX improvement was rather limited, mostly because the friction when you use reactivity transform, when you go past the values in and out of functions or across component boundaries, you need to pass the reactive variable into a function that's imported from an external file, right? At all these boundaries, you have to still think about the conversion between a reactive variable and a ref. So so while it reduced the mental overhead in one area and introduced new mental overhead in another place, it is also less obvious when after you use reactivity transform, it also becomes less obvious on whether a variable is actually reactive because it looks like a normal variable assignment. So when this is okay, kind of okay inside a component itself, but because reactivity transform is designed to be usable outside of components as well, and we discovered that when it's applied in normal JSTS files, it just makes the code actually a little bit harder to understand because the distinction between reactive and non-reactive variables is now lost. So, and finally, obviously, there is the risk of fragmentation because it's yet another way for you to write your components. And so considering overall these, combine all these considerations together, and with discussion with the team, so the team has essentially unanimously agreed to drop the reactivity transform. So it was marked as an experimental feature, so it does mean, so if you have been using it in production, it won't suddenly break. So in 3.3, we will start receiving a new warning telling you you are using a feature, experimental feature that has been deprecated, and you should start migrating away from it, or start using a new package which we will provide. So likely in Vue macros, which I believe Kevin has already implemented support for in Vue macros. So you can start migrating to use Vue macros for reactivity transform if you do intend using it, but it will no longer be a Vue core feature. And in 3.4, it will be officially removed from Vue core, so you will have to start use external packages if you still intend to use it. So there's something that's useful that came out of the whole proposal, because we believe the reactive props destructure will still be quite useful. In that previously, if you want to define props with defaults, we have to use this quite awkward with defaults helper. And you would have to remember, do not destructure here, because otherwise you will lose reactivity for the props that are coming from parents. So you will always have to remember to do props foo previously. So with reactive props destructure, you can use the native JavaScript syntax. When you destructure, this destructure value will automatically be kept reactive. So you no longer need to worry about losing reactivity when destructuring props. And also, you can use the native default syntax for declaring default values. So you no longer need this awkward with defaults helper. And it just looks much cleaner. And also, when you are not using TypeScript, without the type signature, we can actually infer the props that you intend to declare directly from here. So you don't even need runtime declarations when you're not using types, unless you want to do custom validators, that is. OK, so Q2, we intend to bring along a bunch of server-side rendering-related improvements. So this will likely be done in coordination with the Nux team. We want to finalize the suspense API, lift it out of experimental. We intend to introduce lazy hydration at async component boundaries so that you can have custom strategies on how an async component tree should be hydrated. For example, if you have a long page where many components are actually below the fold, you can say delay the hydration until it scrolls into view, or delay the hydration until the user mouse hovers over it with the intention to interaction. So we will come up with, we will post an RFC with the detailed design before we implement it. And then we're also exploring the ability to declare a piece of your template to be server-side rendering only. So an example of that is, for example, is that you are fetching some data from your database, and you're using that data in your templates. So this piece of data is static at the front, in the front end. So on the front end, you know that they will never change. But we're still using a dynamic binding in our templates because it needs to be used during server-side rendering. So we want to give you a way to declare that although this template contains dynamic binding, it doesn't actually change on the client. So when we're doing the client build, we can ignore all these dynamic bindings and somehow compile them differently so that on the client, it's just a placeholder. It'll just pick up the markup that's already there and don't need to actually do any work during hydration. We also intend to provide better hydration mismatch warnings, so it makes it easier to debug when you run into it in production. So these are not all, and to be clear, a lot of these are kind of the tentative plans. A lot of the details will be finalized when we actually start working with the RFCs. So the discussion process will be open, so make sure to stay tuned and get involved. So Q3 and Q4 will be focused on vapor mode. So I've mentioned this a few times in past talks, but the gist of the idea is vapor mode is an opt-in, performance-oriented compilation mode for single-file components. So the keyword here is that, first of all, it's opt-in. Second of all, it's a compilation mode, which means it's not some new API that you need to learn or some new way to write a component. It is the same syntax, the same APIs. It's just that the compiler will do something different to make it more efficient. So at the beginning, we do intend to only support a subset of the current Vue APIs. So namely, it will start with composition API and script setup only, so that we can make sure we squeeze out the maximum performance possible. But the subset of the APIs that are supported will be fully compatible. It will work 100% the same with the way that you know right now. So technically, if your component uses APIs within this subset, you can just swap easily, choose which mode that you want to use it in. So a vapor mode component can be embedded in any existing Vue 3 app. So this is seamless integration. You don't need to change anything. We will show an example of how to opt into it in a later slide. So at the very least, if you have a big current Vue 3 application, but you have some parts that are performance critical, you want to improve its performance, you can then opt into vapor mode for a subtree of your application so that that page will get better performance, while the rest can still leverage whatever existing libraries that you use. But the eventual goal that we do hope to achieve is freely mixed usage, which means you can use vapor components in a normal Vue component, and you can then use the normal component in a normal Vue component inside a vapor Vue component. So you can mix and match them across the tree. So to explain it a bit more about how this compilation strategy works, we need to go back to thinking about how Vue renders stuff. So in Vue 2, Vue has always retained the same reactivity system throughout Vue 1. It has always been fine-grained, dependency tracking-based reactivity. But the rendering strategy has been changing over time. So in Vue 2, we were using a pure virtual DOM, which means it's just the same virtual DOM that similar to what React uses, and it doesn't really do any compile time optimizations. Well, a little bit, but really not much. So the result of this is when we have a whole application with a bunch of components, we achieve fine-grained app level. So at the component tree or the app level, we achieve fine-grained updates by having each component track its own dependencies. So we are fine-grained at the component tree level, but inside that specific component's template, at the template level, it's coarse-grained, because the way virtual DOM works is it'll always recreate a new virtual DOM tree and then diff it from the root, right? So the cost of recreating virtual DOM nodes and then walking through that tree for diffing is the overhead that we talk about when we talk about virtual DOM. And Vue 2 is constantly paying that overhead. So in Vue 3, we did the improvement that we did is compiler-informed virtual DOM. We did a lot more optimization at compile time. So we do talk about this in our docs. There is a page called Rendering Mechanisms. If you haven't checked it out, make sure to read it. So here, I'll only go over it very briefly. There are two major optimizations that we do. The first is patch flags. Essentially, for each binding that you write in your template, we encode a binary flag so that the runtime knows exactly what kind of updates this specific node needs. And the second is called block tree optimizations. So we divide a template into nested blocks at vif and v4 level. So these are structural directives. And inside each block, the node structure is known to be stable. So we just flatten all the dynamic bindings inside each block. So essentially, previously, when you traverse a whole virtual DOM tree, you may have to traverse like 20 levels deep, where you have to do like 100 nodes. But with block tree, you can theoretically compress it to make the traversal cost proportional to how many dynamic bindings there are in the template. So this makes it semi-fine-grained at the component level. But it's still not completely fine-grained because we are still paying the overhead of recreating virtual DOM nodes. And this creates additional memory pressure, and we're still not completely eliminating the cost of walking down the tree and compare things. So Vapor mode is a compilation mode that takes inspiration from a new framework called Solid. And on the left, we see a very typical Vue component. This is the most basic a counter component with a button, and it's just using the normal script setup API that we know. And on the right, this is the output. So first of all, in Vapor mode, because we limit the subset of APIs you can use, there are a lot of assumptions that we can assume. For example, the component can be compiled into just a simple function call. So this even reduces the need of the existence of a component instance, which is in fact one of the most expensive things in large Vue applications. When you have 1,000 Vue component instances, the memory overhead and creating these component instances, creating its internal proxies and all that, we can actually drop that. So this makes component a not zero cost, but make the cost of component abstraction much, much, much cheaper. So you can stop worrying about whether I'm having too many component instances in the app. The second thing is we abstract all the static parts of the template into a string. So this is specialized for DOM rendering. This is to note. So Vapor mode is specialized for in-browser DOM usage. So we create a new instance of this string template, which is extremely fast, and then use Vue's fine-grained reactivity system with ref and effect. So think of this as watch effect equivalent. Inside the effect, we directly set the text. We instantiate the DOM itself, locate the actual button that we want to do bindings on, and then inside the reactive effect, we set the text. So this effect will track the count that we're using. And every time the count changes, we directly go to just, say, set the text on the button. There's no generating a virtual DOM, then trying to compare it, then finally figuring out, OK, this button's text needs changing. There's none of that. It's just going directly from change to boom, set the text. So eliminating all the intermediate steps of figuring out what changed and directly encoding it in the generated code at compile time. So this is also a helper on getting the event handler bounded. And you can see all of these are actually living in the same scope. So there's very little that the compiler needs to do, very little magic that the component needs to do. Because I hope this also shows why we are only supporting script setup. Because script setup, the syntax here, is what enables us to compile it into such an efficient format. Because they all live in the same scope. So this allows us to essentially implement rendering with fine-grained rendering down to the block or even binding level. So we'll still try to benchmark, compare between block level granularity and binding level granularity to find the best possible rendering strategy, but this is the general idea. So some preliminary benchmark. So based on JS framework benchmark. So this is only one benchmark, and it's not really, this number will probably change when it finally lands. So this is all just tentative numbers. Don't take it for the word of truth right now. But the general idea during prototyping phase is that Vanilla.js 1.0 being the baseline, and these are standard deviations. Vapor is 1.08. Vue 3 currently is 1.25, and Vue 2 is 1.82. So these are lower the better, obviously. Memory usage, Vapor probably uses less than half the memory that current Vue 3 rendering strategy uses. So that's also a big improvement. So the way for you to actually use it is very simple. So name a component .vapor.vue, and it will be compiled using Vapor mode. That's it. Then you import that component and use it just like normal. If you use a feature that's not supported in Vapor mode inside a Vapor mode component, you'll get a compilation error. It's telling you this feature is currently not supported yet. Another way to use it, so this is opting at the component level. So this means you can just use this in any existing app you currently have. But you can also opt in at the app level. So use create app, but import it from vue/vapor, and then import your vapor app root app, vapor mode root app. An app created this way completely forgoes virtual DOM interop, so it doesn't even need to pull in the virtual DOM related code at all. So a component written this way, an app compiled this way, will only include Vue reactivity and the vapor mode runtime helpers, which are extremely lightweight. So a component compiled this way probably weighs around 5 to 6 kilobytes. So that will make it suitable for, say, building one-off embedded widgets as web components embedded on any page with a very low baseline runtime cost. All right, so that's it for vapor mode. So let's go into some ecosystem updates. Obviously, I don't need to repeat this, but Vite matured in 2022 and adoption exploded. It was a great year for Vite, and you heard me talking about it in the video leading up to this. And Volar.js, this is Volar, which is our official language tool, which brings all the enhanced IDE and TypeScript experience you now have with Vue 3. So we're extracting the core into something framework agnostic, specifically designed to deal with file formats with embedded languages. So the old Volar extension will be moved to the repository Vue.js/language tools. So to just more clearly indicate what it does. In fact, this move has already happened. Johnson will work on it full-time with support from Stackblitz. So to focus more on improving Volar.js and in turn improve all the support for Vue and other things that may depend on Volar.js in the future, for example, Svelte or Astral or I don't know. We hope to see more adoption in that front. And VitePress, how many of you have used VitePress? Not many. How many of you have used VuePress? Okay, so VitePress is essentially the spiritual successor of VuePress, with the main difference being that it uses Vite instead of Webpack and Vue 3 instead of Vue 2. So we do have a VuePress Next project that's previously being in the works, but we decided that VitePress is, because it's a fresh ground up without the burden of having to maintain design compatibility with old VuePress, it overall provides a much leaner and faster implementation for both DX and the generated sites. So we've been hard at work trying to fixing bugs and finalizing the default theme styling, and VitePress 1.0 is coming soon, so stay tuned. We also have some great advancements in Vue 3 docs translations. So we already have simplified Chinese and Japanese completed. There are also two other languages, Ukrainian and French, both crossing the 50% completion rate. So they're already deployed on official Vue domains. So if you are native speaker of these languages, or there are other languages that are looking for collaborators, help us translate docs into more languages. You can find this link in the slides share later, or you can go to our website and look at the language dropdown. There will be a link taking you to the action steps that if you want to join translations. We announced the certification program in collaboration with Vue School. So this will be a program where it allows you to go through a bunch of tests and get a certification verifying your capability as a Vue developer. So this will be coming soon. I think Vue School is hoping to launch this in March. So this is another thing I want to mention. And then a question that a lot of people were kind of asking around. I've also mentioned this quite a few times in the past. The end of life for Vue 2, the end of support for Vue 2 is December 31st, 2023. That's the end of this year. So if you have a project that is currently using Vue 2 and intends to use it beyond this date, we wrote something up on the Vue 2 website detailing your options. So there are different options, right? So you can choose to upgrade or choose to stay on Vue 2. Both are viable. So make sure to check out the article. If you go to v2.vuejs.org, we do have a banner that links to a page that gives you these options. And if you do intend to stay on Vue 2 for the long term, you can purchase paid extended LTS in partnership with Hero Devs, so that you don't have. So it's essentially a decision between whether you want to pay the cost of migration, or do you want to just stay on Vue 2 with the ease of mind. So it's really up to you. And either way, we want to make sure like all options are possible for Vue 2 users. So. And then there are more Vue conferences coming up in 2023. Not just this one, we also have Vue.js Live in May, that's in London, May 12th. And then VueConf US, May 24th and 26th in New Orleans. And VueFest Japan, which is going to be announced. I think the organization work is being planned right now, and we'll have a date announced later in the year. So if you happen to plan to travel to around these places later in the year, make sure to keep an eye out. And I believe VueConf US and Vue.js Live's call for proposals are already closed, but you can try the Japan one, maybe. And that's it. Thank you very much. Okay.
Thank you so much, Evan. It's always nice to hear from you about the upcoming upgrades and improvements to the Vue ecosystem. Who's excited about Vapor mode and faster build and test setup? I mean, come on.
Thank you. Okay.
Thank you so much.